What methods are used for stress analysis in mechanical engineering? Have you ever wondered how engineers ensure that structures can withstand the forces they encounter? Stress analysis is key to this process. It helps determine how materials and components behave under different loads. Let's break down the methods used in mechanical engineering for stress analysis. First up are analytical methods. These techniques involve solving mathematical equations that describe how materials respond to forces. Engineers use differential equations based on Newton's laws and the Euler-Cauchy stress principle. This approach works well for simple shapes like beams and plates, where solutions can be calculated directly. Next, we have finite element analysis, often called FEA. This method takes a complex structure and divides it into smaller, manageable pieces known as elements. Each element is analyzed separately, allowing engineers to tackle complicated shapes and loading conditions. FEA is commonly used to predict how stress is distributed across components like turbine blades and automotive parts. It's essential to interpret the results carefully to ensure accuracy. Then, there are experimental methods. These involve physical testing to gather real-world data. Techniques like strain gauging measure how much a material deforms under load. Photoelasticity uses polarized light to show stress patterns in clear models. This hands-on approach helps validate the results from analytical and numerical methods. For quick assessments, engineers often relying on simplified models based on classical mechanics. These models address basic scenarios like tension, compression, and bending. They provide fast estimates of stress, guiding initial design choices before more detailed analysis is conducted. Lastly, stress analysis plays a vital role in design optimization. By simulating different load cases and design variations, engineers can refine shapes and materials. This process improves performance while also reducing weight and costs. In practice, mechanical engineers typically combine these methods. They start with simple calculations, move on to detailed finite element analysis, and validate their findings with experimental tests when needed. This layered approach ensures that mechanical components and systems are designed reliably and efficiently.